Today's episode of the FHIR TLW video series provides a summary of a FHIR DevDays talk by Joshua Kelly. 9 key problems when connecting to 400 plus FHIR servers. I can certainly imagine that there would be some issues. The usual caveat, any sudden jumps in the presentation content are due to my video editing, so don't blame the speaker.
We want to build a patient application that connects to any patient access API on a FHIR server out there in the wild, and that can discover all of the resources that are actually available on that server. This is a problem that Flexba, the company that I co-founded, has attempted to do. So in production today, we connect to 416 FHIR Patient Access APIs. So we connect to all of them, so hundreds of FHIR servers, and we have run into some problems. And I'm going to introduce 9 problems to you. So if you connect to a FHIR API on behalf of a patient and want to get all of the patient's data, there seems to be a pretty straightforward solution. It's the patient everything operation. It's really nice. One request, we get back patient data. We ran into some problems with this. First of all, in the network that we're creating, fewer than a third of the payers actually support this operation. It was never considered in the IG development for payer patient access APIs here in the States. Okay, well, maybe we can use batch transaction. So this is interesting. Before I started looking at this problem, I didn't realize you could do this, but you can do a batch transaction with read and search operations. Again, this is actually uncommonly supported by the patient access APIs. We simply stopped trying to do this. And again, this is a theme of many potential solutions and nerd sniped ideas for me. Obviously, our fallback has to be something like doing individual search operations. Great, we're rolling, except that capability statements don't always tell the truth, both in terms of over and under advertisement. So under advertising the resources that are actually supported, under advertising the operations that are supported, so under advertising support for everything, as an example. They don't always fully disclose the search parameters. Then once you get down into this, there's also just weird connectivity requirements in actually sending the FHIR requests. Some implementations require extra headers. Basically, there's a world of non-spec problems that you'll run into when you connect to 400 of these things. And then we get into race conditions. So this will make more sense on the next slide, but you really have to be careful about the order in which you're doing these operations. And the reason for that is once you have returned a page of search operations, you need to process those resources and resolve all of the references that exist inside of them. So this is pretty straightforward graph traversal. So we're going to walk the nodes of all of the resources, find the references, make read operations. But we also need to keep track of which read operations for which resources we have made. And if we're doing searches, individual searches, those searches may actually be returning to us the resources that we're attempting to resolve. A bunch of problems with reference resolution. Certainly rate limits is one. There's recursion depth. So how many times are we going to recurse this? And the duplication of effort or race conditions I just mentioned. And again, why not just use include? As a nerd snipe here, again, there's no guarantee of support at all. So dealing with rate limits, well, certainly if you're making hundreds of potential requests to a FHIR server, you're going to run into problems. You will need to implement HTTP connection pooling at some point. Problems here. So 429 is an HTTP status code that basically says retry later. That's not part of the FHIR spec. It's very rarely supported. It's supported generally at the load balancer level of whatever implementation in the cloud the implementer has used. So those errors are generally not coming back as operation outcomes. Also, don't go too slowly, because if you go too slowly, your authorization could expire. So this was where I think we get into some even more interesting problems. So that we've really done the work of discovering and finding the resources. Now we need to process them and store them. And we have a really, really basic problem, which is that there's, in FHIR, logical identifiers are just strings, right? There's no guarantee that they're unique. So if you're connecting to 400 different endpoints, you could and should expect collisions. So there's a clever solution to this, which is that you can rewrite the IDs using UUID v5, which creates a hash over a namespace. So this is kind of cool because if you input the same patient ID, for example, if you have a patient resource that has a logical identifier of 1, 2, 3, I can consistently create a hash that outputs a UUID given a namespace. So this example here of assigning an ID to each endpoint and then passing in an endpoint and a patient ID means that for each endpoint, I can create a consistently unique patient ID that is also reproducible if I encounter that resource again in the future. Okay, but that creates broken references. So if I'm rewriting identifiers, logical identifiers, every reference to the old logical identifier that I've processed will be broken. Okay, so we need to fix all of the references and all of the resources. This is not such a hard problem. We can keep a map where the key is the old identifier and that maps to our new UUID v5. So this problem is more annoying than it is difficult to solve. Problem number 8, resource validation. So of course, if you are connecting to hundreds of FHIR servers, the general advice on validation is just good luck. You probably need to adjust your expectations. Problem number 9 is now that we're ready, we've transformed, we've changed logical identifiers, we've solved the problem of extracting data. Okay, we may have 1,000 resources. We may have 10,000 resources. We may have 20 or 30,000 resources. So the general advice here is, well, definitely use batch transaction and use update as create. So this is a fun trick in FHIR. Not every server supports it, but you should probably use one that does if you're doing this. Bulk data import, question mark. That would be nice. It is technically in a draft state. So coming up on the last little bit here, and I'll take some questions. Generally speaking, solutions to this problem are, can't we just use X? Well, yes, but X is very rarely always supported, and you just have to layer solutions. You have to go down to the lowest common denominator as a fallback when you're connecting to hundreds of FHIR endpoints.
Performance requirements need to be pinned down extremely well in large-scale implementations. And you probably need some form of stick to motivate those that are non-compliant to fix your implementation. In the meantime, Joshua recommends that you have the ability at least to fall back on the lowest common denominator. And that certainly sounds practical. As a FHIR educator, I'm pleased to offer you best practices and interesting viewpoints in this video series. Please visit our blog to see additional videos.